G'day guys, I've been asked to do this applications of differentiation question for you today, focusing specifically on incremental change or small changes in x that lead to small changes in y. So what we've been given the radius of a circle is increased from 2 to 2.02 meters. First we have to estimate the resulting change in area and then express the estimate as a percentage of the circle's original area. Okay, so the approximation formula that we use for differentiation is we have the incremental change of y with respect to x can be approximated for small changes in x to the actual derivative of y with respect to x, evaluated at some arbitrary point. Cool. So what we can do here is the reason that we have this relationship is so we can find a small change in the dependent variable and we can approximate it using the derivative with respect to x evaluated at that original point, that arbitrary original point, and then we multiply it by the small change in our independent variable. So in this case, we've got, rather than y as a function of x, we're going to have area as a function of radius. So hopefully you guys are well aware that the area of a circle, area is equal to pi r squared. So we can differentiate this, so we can have dA dr. It's going to be equal to, just take the 2 down, 2 pi r, and then the 2 goes to 1, so it's unnecessary. Cool. So what we can do here is we can say that the small change in y, or in this case the small change for part A, the small change in area is going to be equal to the derivative of area with respect to radius evaluated at our initial radius, which is this value here, 2. So r equals 2, and then we're going to multiply it by the small change in the radius. So in this case, we are going from 2 to 2.02, so that's just going to be a 0.02 change. So let's do this. We have delta A will be equal to the derivative of A with respect to r, evaluated when r is equal to 2. So we have 2 pi times 2 multiplied by 0.02. Cool, so that's equal to, now 0.02 is 1 over 50, so we have 4 pi on 50, which is equal to 2 pi on 25, and the units that we have is meters squared because it's area. We could approximate that, but why approximate that value when we can give an exact value? So let's do B. We'll just separate this out. We've got B. Now it's asking us to express the estimate as a percentage of the circle's original area. So what we've been asked to do is we've been asked to calculate delta A divided by A. That's what we're looking for. That's the percentage area as a decimal. So what we do is we have a delta A expression, this 2 pi r times 0.02, or 2 pi r times 1 over 50. So what we're going to do is we're going to go delta A divided by A is equal to, well, what is delta A? Is 2 pi r times 0.02, or 2 pi r on 50. And then what we're going to do is we're going to multiply it, or you could say divide it by area, because we've got to divide this side by area as well. So we're going to times this by 1 on A. So what I've done is I've got our original delta A formula, and I have divided both sides by A. So I haven't really changed anything yet. So then I've got this delta A on A is equal to, I'm going to get rid of the 2, and I'm going to call this just pi r over 25 times by 1 on area. Now the area of a circle, again, we're going to change that out, and that's equal to pi r squared. Cool. So then what we do is we take a red pen and we simplify this. So the pi's can cancel out, and this r will cancel with one of the squareds, and the percentage change, or delta A divided by A, is going to equal to 1 over 25r. And seeing is r is equal to 2, we're going to be equal to 1 on 50, which is equal to 2%. Cool. So basically, guys, what we have to do with these formulas is we have to, or these sort of questions, is we have to be well acquainted with this approximation formula. We have to understand that for small changes in the independent variable, it's called linearization. We can linearize the function to approximate small changes in the dependent variable. So what we can do is, if we have this relationship, we can use a little bit of, year like 3 algebra to take the delta x to the other side, and then we can have an expression that expresses a small change in y with regards to a small change in x. For the first part, we just then have to enter in all the variables that we have, and then it'll pop out with an answer. For part B, it's a little bit more tricky, but essentially, to express the estimate as a percentage of the circle's original area, what you're going to do is you're going to get this small change in area and divide it by its original area, or A. So what you can do there is you get your formula that we worked out in part A, this one here, and you divide both sides by A. What we then do is, on the right hand side, we then substitute what A is in terms of R. So we know that the area of a circle is pi r squared. You then simplify it a little bit, you come up with this, you enter in your value, you get this, and then it pops out with your final solution. So it's not a very complicated question, guys, and again, I've got a lot of these videos on my channel, so if this one here you're still a bit stuck, have a look at one of the other ones. I'll leave a link to it on the screen, and yeah, just keep practicing them, guys, and while you do it, just make sure you enjoy it. Have fun. See you next time.